Hi, Honors Chem. Hope everybody's doing well. I decided since I decided not to Google Meet this week and just do a video and work through some molarity practice problems on your practice sheet. So if you look at the assignment for Friday, it's to work through some practice problems. So the practice problems I'm talking about are in the classwork section, and they are the first one. So hopefully you finished the ed puzzle on molarity. Hopefully the solubility curve assignment is done. I'm going to try to grade those tonight. But the molarity practice problems, that is this assignment right here. So once you finish it, I want you to try to upload it by Monday. That way I can take a look at it and see if there's anything else that we have to cover in class on Monday. The worksheet that I'm talking about is actually this one right here. And if you print it off, great. If you don't print it off, you can just work these problems out on a separate sheet of paper, take a PDF picture and send it to me. The top part right here where it says notes and other important information, what I like with this is for you to write down, definitions, reminders, formulas and things like that. So for example, M stands for molarity, and molarity is equal to moles of solute per liter of solution. And some important things you might want to know is M stands for molarity, which is also the same thing as concentration. You want to notice that the volume must be in liters, and that volume is actually the volume of the solution, not just the water. So having, let's say, 100 milliliters or 1.1 liters of a salt solution is not the same as having 0.1 liter of water. The solute actually takes up some of that volume, so it's the total volume of the solution. And then the solute, which is what it's being dissolved, has to be in moles. And so if you're given grams, you're going to have to use molar mass to figure out what the actual number of moles are that you have. So we're going to work through a few problems. One of the things I want you to notice is on the very last page down at the bottom, there is an answer key. So as you're working through these, you can kind of check your answers. So I'm going to work, I think, 4 of these problems out up till a point, and then you can calculate it out. So you should have a calculator in front of you, a periodic table, because you're going to need to find molar masses to work these out. So let's take a look at, let's go ahead and take a look at just question number 1 really quick. Question number 1 is a really basic, straightforward question. If you take a look at what you're given moles and you're given volume in liters. So you actually don't have to convert anything. You want to calculate the molarity or the concentration of each solution. Now, we know that the units have to be in moles per liter. That tells you what the formula is. So when the units are moles per liter, that means that you're going to basically take moles and divide it by the number of liters you have. So for this one, molarity is equal to 2.30 moles of NaCl all over 0.450 liters of solution. So remember, if you were given milliliters, you have to convert to liters. So something you might want to write down at the top of here is that there are 1,000 milliliters in 1 liter. So you might need that information later. And that's it. You just have to divide, and should have 3 significant digits in this answer. So hopefully you work that out. We're going to go ahead and we're going to take a look at number 4. So I'm going to move this up a little bit to number 4. All right, so for number 4, we have 12 grams of calcium nitrate. Yeah, you have to know how to write the formula for calcium nitrate. And so calcium has a +2 charge, so Ca with a 2+, And nitrate is NO3 with a minus charge. So using the balancing the charge method or crisscross method, your formula is going to be CaNO3, and there are 2 of them. Okay, I did a little work ahead. I got a molar mass on this one of 164.10 grams per mole. Okay. So what I want you to pay attention to is notice that grams per mole is actually a conversion factor. Now, we're still looking for molarity, so we want moles per liter to be our final units. A couple ways you can do this. You could separately take your molar mass and calculate how many moles you have, and then just plug it into the formula. I'm going to set mine up a little bit differently. I'm going to use dimensional analysis with this. And what I know is I want my units to be moles per liter. And I want it to be basically moles of calcium nitrate, CaNO3, 2 per liter of solution. So I'm actually going to start with the one thing that I'm given here, which is 12 grams of calcium nitrate. I'm trying to convert 12 grams of calcium nitrate into molarity. And so in my conversion factor, I need to get rid of that unit right there. I need to get rid of grams. So if I look at my molar mass right here, I've got 164.10 grams per mole, and I want moles on top. So I'm actually going to flip that, and I'm going to say for every 1 mole of calcium nitrate, I should have a mass of 164.10 grams. CaNO3, 2. All right. And even though, we're not working these out together, make it a habit of writing all your units and paying attention to sig figs. So don't forget all that stuff we've been doing all year. That allows us to calculate our, get rid of grams in this problem, and that gives us moles. Now, the other thing that we'll notice is we have 240 milliliters. And if you remember, we said that the volume has to be in liters. So 240 milliliters ends up 240.0 milliliters. And we know that there are 1,000 milliliters in 1 liter. And so milliliters cancels out. So that gives us, let's see, we'll slide this over here, 0.2400 liters of solution. Okay. So what you can do from this point, if you wanted to, you could have put this 12 grams over the volume, the 0.02400 liters, or you could calculate the number of moles you get here and then just divide by the volume. So remember, molarity is moles per liter. So what I'm going to do is I'm going to go back and I'm going to say, all right, I know I've got 12 grams of calcium nitrate, and that's the volume of solution I had. In liters, it's 0.2400 liters. Now what happens is I've got my units right where I want them. And everything that I have there is a conversion factor because each statement is true. There were 12 grams of calcium nitrate in that volume of solution. And I know 1 mole of calcium nitrate does equal 64.10 grams. So those are both true statements. And so I can use that to calculate out my answer. See what you can do with that. The 12.0 grams should give you 3 significant digits. So try that out and see what you can do with it. Last one I think I'm going to do. Let's go ahead and try question number 8. And then maybe we'll do one more on the back. So question number 8 right here, we've got 50 milliliters of 0.250 molar sodium sulfate. Now the question here is how many grams of solid would you need to actually mass out on a balance to try to make that solution? So in other words, when we're in lab and I make solutions, a lot of times I figure out about what volume I want, what concentration I want, and then I work backwards and I figure out how many grams of that solid I actually have to mass out. So that's kind of what we're doing. This really is the typical calculation that you would do in a concentration type problem. So in this one, we actually want to end up with grams. So I want you to think about this a little bit. We know that we've got 50 milliliters of a 0.250 molar sodium sulfate solution. Remember, molarity is moles per liter. And so I'm actually going to substitute moles per liter in for molarity. And the other thing I'm going to do right off the bat is I'm going to change this to liters. And so that's going to be 0.05000 liters if I keep all those significant zeros. So I'm going to start off with my volume. And the reason I know I can start off with my volume is because my units for molarity in moles per liter, if I use that, I'm going to be able to actually get rid of liters. So I know I have 0.250 moles of Na2SO4 for every 1 liter of solution. Then liters cancels. Now, if the problem was asking how many moles of each solid, we'd be done because we would have moles. But balances don't mass things out in moles. They mass things out in grams. So again, we're going to need the molar mass. So for this one, for Na2SO4, I know that 1 mole of Na2SO4 has a mass of, what is this, sodium sulfate? 142.05 grams. And so that is my molar mass. Moles cancel, and I'm left with grams, which is what I want. So when you're all done, you should get an answer that says grams of Na2SO4. And that should do it. 3 significant digits here again because that concentration. Okay. Let's maybe do one more calculation sort of similar to this on the back page. Let's go ahead and do, let's do number 13. Actually, no. Let's go ahead and do 11. How many grams of potassium carbonate are needed to make 200 milliliters of a 0.25 molar solution? So again, potassium carbonate is K2CO3, and this has a molar mass of 138.21 grams per mole. 200 milliliters is 0.2000 liters. And we actually have everything that we need now to solve this one. Think about what you want. You want mass. So we need to make sure that we end up with grams. So the first thing I'm going to do is I'm going to start with the one thing that's by itself. Now this looks like it's by itself, and this looks kind of like it's by itself. But remember, molarity actually is a conversion factor. It's moles per liter. So I'm going to use that as a conversion. I'm going to use that to get rid of my volume. So the first thing I want to do is say, okay, if I know that there are 0.250 moles of potassium carbonate per liter of solution, and I have way less than a liter, let's figure out then how many moles I have. So 0.200 liters of solution. And I know that there are 2.50 moles of potassium carbonate, K2CO3, for every 1 liter. That's going to get me how many moles I would have in 0.2 liters, but I'm not going to stop at that point because I want to just keep going with this problem. I don't want to have several like little steps where I calculate and I take that answer and I calculate again and I take that answer and I calculate again. But I do want grams and I want moles to cancel now. And so taking a look at molar mass, 138.21 grams of K2CO3 for every 1 mole of K2CO3. That allows moles to cancel. And if you calculate that through, you should end up with some grams of K2CO3. All right, so that's the last one. Try these out for Monday, and then we will talk about whether or not you've got some questions on that. All right, other than that, we'll talk to you later.